Here we need to talk about electricity. See, electricity, we all are familiar. What is electricity? Actually, it is nothing but the flow of electrons. So there are two ways the electrical conduction can happen. One is electronic conduction. Okay. Then the next one is electrolytic conduction. Electronic conduction and electrolytic conduction. So here actually we are. I will tell you one particular example. Let's take one zinc electrode, and in next one it is a copper electrode. Okay, the zinc electrode and copper electrode. So when you are connecting zinc electrode with the copper electrode, what shall happen is, nothing will happen. So this voltmeter reading, it will remain same and no change in anything will be there. But on the other hand, if you are dipping this zinc rod and copper rod, actually if you are dipping this zinc rod and copper rod, see, zinc rod you dip into zinc sulfate solution. Think in this way, you dip into zinc sulfate solution. Here actually this copper rod, you dip into copper sulfate solution. Do you know one thing? You can think that you can check that the voltmeter, it is getting deflected and the deflection shall be happening. So here what you can understand, what you can understand is if you are looking very closely, what is going to happen, what is happening. We will write here what is happening. Here actually this zinc rod. Okay, so this is going to dissociate into Zn2++, 2 electrons. Okay, and these 2 electrons are there, right? Actually, because when it is when this zinc rod, it is dipping into zinc sulfate solution. So this zinc started getting oxidized. Zinc started getting oxidized. This is 2 electron. This 2 electron shall be actually it will be moving through this wire, and so that the electron flow will cause the voltmeter to deflect. Definitely some deflection is happening, and obviously when these electrons are reaching here, this electrode, copper rod, it will have a negative polarity because electrons shall be here. So here, copper 2 plus ions, when it is accepting 2 electrons, what shall happen is it will have it shall be having Cu. Okay. So actually copper, it accepted this 2 electron, and copper ions will be there because in the solution it contains copper sulfate. So what is the case is copper sulfate will be dissociated into Cu2++, SO4 2 minus. Okay, and the Cu2 plus, of course, that is accepting the electron from 2 electron, and that 2 electron it will deposit on the surface of this copper rod. So what shall be the outcome is, after some time the size of this copper rod will be increasing, and this zinc rod, it is keep on depleting. Okay, so this is a kind of here also the electricity is conducting, that is nothing but the electricity is producing, flow of electrons are happening, that is through the electrolytic process. Okay, let's we are going to see more examples and more illustrations now. In the presence of copper, okay, so we may get a question actually, like instead of zinc, when can we use any other metal? Instead of copper, can we use any other metal? Whether the flow of electrons, whether it is same or it is going to be different. So some questions we may come up, right? So in fact here one thing you should know. Actually zinc and copper, it differs in electrochemical series. You can see the electrochemical series now. Yeah, so you can see the positions within the electrochemical series. Zinc, it is actually on the top, and copper, it is down. So zinc got a more tendency of releasing electrons. So we call it as electrode potential. And copper got, you can see it is actually even below hydrogen, right? So it got a more tendency to accept electrons, or like with respect to zinc, it got a less tendency to release the electrons. Okay, so instead of zinc, you can also use a magnesium. There are any metal combinations you can use. You can also use a potassium. You can also use a sodium. Okay, so magnesium, if you are connecting with the copper, of course, magnesium will be decomposing into. If I write the reaction here, magnesium shall be decomposing into Mg2 plus 2 electrons. Okay, Cu2 plus, if it is accepting 2 electrons, so this is going to be Cu. Okay, so this is how the reaction it will be following. And now, yeah, if it is K, potassium, when it is, it will actually give 2K plus plus and 2 electrons. And so if it is potassium and copper, it is connecting. Cu2 plus, when it is accepting 2 electrons, it gives a Cu. Okay, same way, you can use any combinations, and it depends on, suppose, depends on the metal you are connecting, its electrode potential and the flow, how much current it is flowing, that shall be different. For example, so you can see the electrochemical series again, okay, so you can see the potassium, it is on the top, and again, when it is coming, you can see the copper, it is again, it is almost in the bottom. So if I am using potassium with the copper, okay, and again next one, like below the potassium there is actually, when it is coming down, there is zinc, right? There is zinc, and I am connecting zinc with the copper. Do you know in which case the more electricity will be following, more current will be following? Definitely it is in the case of potassium versus zinc, because in this combination, potassium versus zinc, there is a more flow of electrons are there. There is actually more flow of electrons. There is a more electrode potential difference is there. Okay. So this is the combination that is going to give you more electrons. So that is what we should know. So what I could to tell you is actually more like where the potential difference is more, there the electron flow also shall be going to be high. Okay. Yeah. We already saw how the electricity is being produced in this in an electrolytic cell, right? Okay. See, one of the very common example of electrolytic cell is that is nothing but a fuel cell. So I don't know how many of you are here about fuel cell. See, fuel cell actually, as the time passes, you will come to know it is actually the future of energy. Okay. See, because we are having the fossil fuels that is getting depleted every day, and we can't also use it for long period of time. So definitely our human generation has to go into more sustainable way of living. That is nothing but that is nothing but a fuel cell and similar kind of things. Okay. So we will see what is a fuel cell, why it is called a fuel cell, and how it is getting operated. So this is a schematic representation of a fuel cell. You can see this is a negative electrode, that is nothing but a anode, and this is a positive electrode, that is nothing but a cathode. Okay. So here, do you know what is happening in the case of fuel cell? Hydrogen being one of the fuel, hydrogen will be entering through the fuel cell. Okay. And oxygen is also, it supports in the combustion. So it actually oxygen gas, it shall be entering. We are actually very clear, hydrogen, when it is reacting with oxygen, it forms, okay, H2O, okay, water vapor, right? So what is a water vapor? Water vapor is not a environmental pollutant. It doesn't cause any environmental pollution. It is, you can use for drinking purpose. So it is actually not a harmful substance like a carbon monoxide or a nitrous oxide, similar kind of gases that is being evolved in the combustion process. Okay. So here actually, the electrolyte is nothing but the potassium hydroxide. Potassium hydroxide is the electrolyte, and these two rods. So here actually this is the negative rod, that is again this is the positive rod. These are actually the electrodes. These are carbon based electrode, and this carbon based electrodes we are using for it is actually electrodes. Okay. So the reactions, in the negative electrode also, in the positive electrode also, some reactions shall be happening. So this reactions, it definitely occurs, and as a result of that, the water vapor shall be forming. Okay, as a result of that, the water vapor shall be forming. And let's see what is the reaction happening in the negative electrode. Okay, yeah. So we can see the reaction. I just rewritten here. We can see the reaction that is happening in the anode. So here in the negative electrode. So this 4OH, actually OH minus, it is coming from potassium hydroxide. So that react with hydrogen, and the product is water. You can see what product is. It is nothing but water. The same way, and this 4 electrons shall be releasing. Of course, that passes into the cathode. Let's see what reaction happening in the positive electrode. Let's see that also. Okay. In the positive electrode, what reaction shall be happening? Okay. Yeah. So let's see the reaction that is happening. So actually oxygen, it combines with again. So the oxygen that is being supplied through this, the water, it combines with the water molecule and this 4 electrons, the 4 electrons that is being revolved. So it produces this OH minus ions, this 4 OH minus ions. In fact, this OH minus ions, the same reaction, it consumes in the anode reaction. Actually, this OH minus ions, it can be consumed in this anode, and it forms water. Okay. So this is the reaction, it is happening in the anode as well as in the cathode. So it is in the negative electrode and it is in the positive electrode. Okay. So you can understand here, actually, like in the anode, the water is being produced. Same water, that is consuming in the cathode, and it is producing nothing, actually, like it produces, ultimately the end product is water. Some amount of water will be releasing here, some amount of water will be releasing here. So what is the wastage product? Wastage product is nothing but water, which is not polluting, not environmentally harmful. But the fuel is oxygen and hydrogen. That is here one thing we should know very properly. This oxygen, do you know from where the oxygen is coming? Let's see, actually the commonmost source of oxygen and hydrogen are water. We are going to see how the oxygen and the water is coming. That is nothing through the electrolysis of water. So water is very plenty. There are oceans, there are river. Water is actually 3 by 4th of, major share of our earth is filled with water. Let's see how the reaction is, let's see how the oxygen and hydrogen is coming. Okay. So, when you pass electricity through water, so this water actually, it is split into hydrogen and oxygen. See, now you can understand from where actually the fuel of fuel cell is coming. Hydrogen, and both hydrogen and actually water, it is actually coming from water. So it is coming from the water itself. So water is plenty, that is you can find in the ocean. And now from where this electricity is coming, that is again from the sun. So from the solar panel, actually, okay. So from the sun, it generates enough amount of what we can say, that is enough amount of sunlight, and through the solar panel, actually this electricity is producing, and the electrons shall be going to water, and the water will be splitting into hydrogen and oxygen. So the electricity generation also happening through the solar panel, solar cells. Okay. So everything is sustainable. So electricity comes from the solar panel, and fuel for fuel cell, it is coming from the from the water in the form of hydrogen and oxygen. So this fuel cell, of course, it is going to rule our future, because you can see sooner or later, the hydrogen oxygen fuel cells are going to be operated in automobiles, cars, and every kind of machinery, so that no pollution, nothing will be there, and world will be going to more cleaner